right, so today's lesson we're talking about esters, and let's see, esters are right here. What is an ester? It's where you got a C double bonded to an O, and then connected to that same C is another O. Do we have a picture? We don't have a picture of it, so let's write it.
I made an ester.
Did you make an ester?
Yeah. So.
No, that was, I don't remember. No, you had a lot of stuff going on there. All right, so.
Natalie threw it.
So essentially, that is an ester. And really, I should switch this to an R. It just stands for carbon group. Another carbon chain. So it's kind of like, what's this C double bonded to an O? That's called a carbonyl. And we see carbonyls in ketones. We see carbonyls in aldehydes. We see carbonyls in carboxylic acids. And we see a carbonyl in ester. We also see it in an amide that we're going to talk about, I think, next week. All right. Oh, ester, made from an alcohol and a carboxylic acid. So this is fun. This is where we're actually going to do some chemistry tomorrow. We're going to do an esters lab, making a whole bunch of different smells. So let's just do it. And this is huge for industry. So perfume industry, it's all about esters. Taste industry, it's all about esters. Because smell and taste are very similar. They're sensing the same molecules. All right, so we got a carboxylic carboxylic acid right here. It's 1, 2, 3. What's the name of this? Propanoic acid. Propanoic acid. Let's do another one. Let's do something like this. But that's an OH. 1, 2, 3. What's this one? Oh no, let's do this. Oh, what's that one? 1, 2, 3, 4. Butanol. It's an alcohol because it's got an OH and it's got 1, 2, 3, 4, so it's bute. Alright, so I'm putting the OH and the OH right next to each other because that's where the bonding is going to form for this ester. And what we got is alcohol starts the name but has ill ending instead of an all ending. So we're going to start the name here. Well, hey, this is a chemical reaction. We'll put a little plus sign there. Got propanoic acid plus butanol equals, what's this going to look like? So we got the carbonyl, and this oxygen is going to stick around, and the OH is going to leave. So that's going to break, and that's going to break. And it's going to connect to form 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. And there is our ester. And what is a byproduct of an esterification reaction?
H2O.
H2O, you got it. Plus H2O. So this is a type of condensation reaction. It's called esterification because it's the formation of ester, and you need a catalyst for this to happen. You're going to see this firsthand tomorrow. And so we're going to put the catalyst above the reaction arrow, and it is concentrated H2SO4. So it's going to be like a couple of drops just to get it rolling, and then it forms the ester. The problem is if you don't do it right, like if you don't have, you don't heat it up just enough, or maybe you don't have H2SO4 in it, it's going to remain propanoic acid and butanol. And if you have butanoic acid, that's the stuff that really stinks. It smells pretty much like vomit. And they ship it in like it's a cylinder, metal cylinder filled with sand, so the fumes can't escape. But in order to open it, I had to take the sand out. So once you open it, that's why this place is going to stink really bad tomorrow. But if you're successful, vomit will turn into strawberries or other sweet-smelling smells. Success rate's been around 50% for tomorrow.
Or 15.
Tomorrow?
It's all 50. It's hit or miss. Yeah. All right. Yeah, don't wear your nicest clothing, and then explain to the person next to you in your next class.
Yeah,
I did shower this morning.
Oh no! I don't know.
Oh, tomorrow we have to wear show shirts.
Oh
Ew.
no.
Oh, the shorts we wear in the show too. Oh, my costume's gonna smell nasty.
No, it's not too bad. It's just slightly faint. So. Sorry, I guess I didn't play that one too well there.
I'm gonna change this. I don't want to smell like poopy.
It's mostly the room is gonna stink. So, and then those that have to sit here for like 2 more hours usually leave with a headache. So I'll have those. Is it gonna be cold tomorrow too?
Yeah, it's supposed to snow a lot in the afternoon, like heavy.
Usually open the windows.
Yeah, hard or snow tomorrow afternoon.
Really?
Yeah, blow it on the Laurier's.
Yeah.
Yeah, Hebner. Put the thing right there and blow it on the Laurier's.
That would be cruel. Yeah, I'll have to bring a fan. Okay, guys, we're going to work on naming these esters, so there's not a whole lot of practice. So we'll get to start the lab today, like the written part, not the actual chemical part.
Yeah, I don't want to smell stinky.
All right. So, guys, the alcohol starts the name. The alcohol starts the name. So this is convenient because we showed both parts, but here you're going to have to dissect it and figure out. All right. So we know that butanol, all right, we're going to call it butyl, because instead of anol, it's ill, so it's butyl. And then name for acid part ends, butyric acid becomes 8. So ends, but. Acid part ends, but. I don't know what that's saying. But instead of ic, you're 8. So this is propanoic acid. It's going to be propanoate. So butyl, and it's separate words. Propanoate. Name for acid part ends. Oh, okay. What is that? A conjunction? I was so confused. Yeah, never mind. Yeah, that butt was throwing me off. All right. All right, let's do this name right here. We got 1, 2, 3. Oh, what's that? This is the ester. Hey, so if I'm circling my functional group, that's what I would circle. That's my ester, this carbonyl with a O coming off. And where do you think, okay, the double bonded, the carbonyl, that's my carboxylic acid. So COO and 1's connected to an H. So right there is my cutoff. So that means my alcohol is 1, 2, 3. That is propanol, but there's a methyl on the second carbon. So we're going to call that 2, any ideas? Methyl. Instead of propanol, we're going to call it propyl. So it's 2-methyl propyl, second word, 1, 2, 3. Not propanoic acid, but
Propanoate.
propanoate.
Wow.
Oh, you guys made it?
Yeah.
Chemistry.
You weren't smoking doobies out back there.
Yeah, they were. Yeah, they were. I think they were. Yeah, oh yeah. Just remember, they still have some if you want it.
No. Okay. All right, let's do another one. Let's do another one. Hey, where's my carboxylic acid, my former carboxylic acid on this one? Yeah, right there. That was the carboxylic acid. So this is my, wait a minute. No, let's see.
No, should it break between the O and the triangle?
It should be right there. There we go. All right. So my alcohol was once a triangle, also known as a cyclopropane, but with an OH would be cyclopropanol. So it was once that, a cyclopropanol, but we're going to call it cyclopropane.
Vanilla.
propyl,
Same thing.
cyclopropyl, and the 1, 2, 3, 4, 5 pentanoic acid is now pentanoate. Yeah, not too bad. It's kind of fun because we were thinking about chemistry and condensation reactions.
I just have how do you know where to split it?
Over, don't worry.
So the carbonyl, C double bonded to an O, is also connected to another O. That's all part of the carboxylic acid. So after the single O,
Okay.
single bonded O.
How do you know
Which
which one's which?
one's which? Like the alcohol and the carboxylic acid? Yeah, so it has to do with basically the ester group is a part of the carboxylic acid. So beyond that, whatever's connected to this oxygen then was the alcohol. So the break is basically after the O, the single bonded O. Every single time. And what are the two products of an esterification reaction? Water and ester. You got it. So the two products of an esterification reaction are water and an ester, and the catalyst required to drive it is H2SO4 concentrate. You got it. It's always H2SO4. Yeah, that's the magic catalyst. All right, that is it. We will press stop on that.